Hello and welcome to yet another video of Cornerstones of Math, and let us jump right into the problem that was teased in my last video. If you haven't seen that video, please check the link in the description or on the top right corner. So now we have quadrilateral ABCD, and points P, Q, R, and S divide the sides AB, BC, CD, and DA in the ratio of m to n respectively. And we have to find the ratio between the area of quadrilateral PQRS and the area of quadrilateral ABCD. So let's do the process similar to my previous video. Basically, the area of quadrilateral PQRS is the area of quadrilateral ABCD minus these four triangles. So we have triangle ASP, BPQ, CQR, and DRS. And if you watched my previous video, you know what to do with these areas. First, for triangle ASP, notice that triangle ASP and triangle ASB have the same height, so the ratio between their areas is equal to the ratio between their base length, which is length AP, to the length AB, which is m to m plus n. Therefore, the area of the triangle ASP is m over m plus n times the area of triangle ASB. And then, if we compare the area of triangle ASB to the area of triangle ADB, which also have the same height, so this ratio is equal to the ratio between length AS and length AD, which is n to m plus n. Therefore, the area of triangle ASB equals n over m plus n times the area of triangle ADB. Therefore, combining these two, we have the area of triangle ASP equals first m over m plus n times this area, which is given like this. So n over m plus n times triangle ADB. So we have mn over m plus n squared times triangle ADB. So we have obtained this relation. However, this triangle ADB is not the entirety of quadrilateral ABCD. So now what? Well, let us do the similar process to other triangles and see what happens. For our next triangle, BPQ, if we compare with triangle BPC, they have the same height, and the ratio between base length is m to m plus n. So we have area of BPQ equals m over m plus n times the area of BPC. And this triangle BPC can be expressed in terms of triangle BAC, which is, now the ratio between base length is this to this. So it is n to m plus n. So we have area of BPQ equals mn over m plus n squared times the area of BAC. And similarly, now for triangle CQR, which is this triangle, first we compare with triangle CQD. Then you will obtain m over m plus n times triangle CQD. Then we compare with triangle CBD. So we have m over m plus n, and the area of triangle CQD can be expressed as n over m plus n times the area of triangle CBD. So we have mn over m plus n squared times the area of CBD. And finally, for the triangle DRS, first we compare with triangle DRA, which will give m over m plus n times the area of DRA. Then we compare with triangle DCA, which gives m over m plus n times now n over m plus n times the area of triangle DCA. So we have mn over m plus n squared times the area of triangle DCA. So now we have the area of these four triangles in terms of other four triangles. Now let's see what happens when we add them up. Notice that coefficients mn over m plus n squared are the same for all four triangles. So we can write mn over m plus n squared at the front. Then we have triangle ADB, BAC, CBD, and then DCA. Here notice that ADB plus CBD, which is this area plus this area, gives the area of quadrilateral ABCD, and this triangle BAC plus triangle DCA also gives the area of quadrilateral ABCD. Therefore, we have mn over m plus n squared times 2 times the area of quadrilateral ABCD. So we can write 2mn over m plus n squared times the area of ABCD. Therefore, this ratio is given as the area of ABCD minus 2mn over m plus n squared times the area of ABCD over the area of ABCD, which gives 1 minus 2mn over m plus n squared, or you can write m squared plus n squared over m plus n squared. And I gotta say, the answer is surprisingly beautiful. So that was all for today's video. Thank you all for watching, and please give a like and also subscribe to my channel for more interesting math problems, and I will see you in another video.